Good morning, secondary 1. Hello with our second term. Hope you be fine, all of you. In this term, in your chemistry curriculum, you have 2 units. Unit 1 is talking about the energy, especially the heat energy, and it contains 4 chapters. And Unit 2 talking about the structure of atoms, and it contains also 4 chapters. So please pay attention this term and study hard. Okay. Today we are going to talk about the first lesson, which is energy. Who can tell me what's meant by energy? Yes, you knew that the energy is the ability to do work. If you have energy, so you can do work. If you don't have energy, you can't do work. Number 1, the law of conservation of energy. In this lesson, we will talk about many concepts. One of them, the law of conservation of energy. What's meant by law of conservation of energy? You took it in Prep 1. Law of conservation of energy says energy neither created nor destroyed. Energy neither created nor destroyed, but it changes from one form to another. This is the law of conservation of energy. The second concept here is thermodynamic. Pay attention when I said thermo is related to the heat energy, and dynamic related to the motion. So what's meant by thermodynamic science? It is a science that is interested about the transformation of energy. The science that is interested about the transformation of energy. And you have another science called thermochemical or thermochemistry. Okay? What's meant by thermochemistry? It is a science that interested for studying the heat energy accompanied with a chemical change or a physical change. Chemical change like any chemical reaction, and physical change like dissolving a substance in water, for example. This is thermochemistry. Okay? The second concept, system and surrounding. What's meant by system and what's meant by surrounding? The system is the place by which the chemical reaction takes place. It is a system of universe, any part of the universe that is chosen for making a chemical reaction. Okay? So the system is the part by which the chemical change takes place. The chemical reaction takes place. And what's meant by surrounding? It is a place that surrounds the system. So in this lesson, you will study system that indicates chemical reaction and the surrounding that indicates the atmospheric air around the system. Types of system. We have 3 types of systems. Number 1, isolated system. Number 2, open system. Number 3, closed system. As you see in the picture. Open system, this is an open system. In this glass or in this bottle, the chemical reaction takes place, and this is called system. And the bottle is called system boundary. The bottle is called system boundary. Okay? And the atmospheric air around or the place by which the chemical reaction takes place, like atmospheric air, like the science lab, like the class, any place around the system is called surrounding. In open system, there are many exchange takes place between the system and surrounding. Here, the matter and energy may exchange between the system and surrounding. This is in an open system. But in closed system, there is exchange in energy between the system and surrounding, but there is no change in matter. Okay? In isolated system, there is there is no exchange between the system and surrounding. There is no exchange between the system and surrounding, even this change is matter or energy. Again, open system, there is exchange between the system and surrounding in energy and matter. Closed system, there is exchange between system and surrounding in energy only. There is no change in matter. Isolated system, there is no change between the system and surrounding, even the change is matter or energy. This is about the systems and the type of systems. Number 2, first law of thermodynamics. Pay attention. The total energy that is gained by the system equal to the total energy that is lost from the surrounding, and vice versa. The energy that is lost by the system equal to the energy that is gained by the surrounding. The same value but opposite sign. Delta E of the system has a positive sign. This means that the system loses energy. The system loses energy. And delta E of surrounding, negative sign. This means that the surrounding gain this energy. Equal value but different sign, and the sign here related to gain or loss. Okay? First law of thermodynamics. First law of thermodynamics is study the isolated system. And this law says that the energy exchange in isolated system is constant. We said that there is no exchange in isolated system, so the energy, total energy in the isolated system is constant. Even the substance change from one state to another. Even the substance in the system change from one form to another. And this is first law of thermodynamics. Okay? The third concept here is heat energy. What's meant by heat energy now? Heat energy is a form of energy that can transfer from the object of high temperature to the object with low temperature until both of them have the same temperature. So, if I have two touching objects, the first one, its temperature is 30 Celsius degree, and the second one, its temperature is 10 Celsius degree. The heat energy will transfer from the object with 30 Celsius degree to the object with 10 Celsius degree until both of them have the same temperature, which is 20. So the lost energy here is 10 Celsius degree and gained energy is 10 Celsius degree. Let's see another concept, which is temperature. Temperature is related to the kinetic energy. By increasing the kinetic energy of the molecules inside the object, the temperature increases, and vice versa. But the molecules move inside the substance by not equal value. Its speed is not equal. So the temperature here related to the average speed, related to the average speed of the molecules inside the object. Pay attention. Temperature related to the average speed of the molecules inside the object, and the average speed I can call it internal energy of the object. internal energy of the object means the average speed of the molecules inside the object. And also the temperature is an indicator of hotness and coldness. So I can define it by two ways. It is an indicator of hotness or coldness, or it is directly proportional with the average speed of the molecules in the object. Okay, this is about the temperature. Okay, let's see the measuring unit of the amount of heat. I can measure the amount of heat by calories or by joule. By calories or by joule. What's meant by calorie? Calorie is an amount of heat that is needed to raise the temperature of 1 gram of pure water by 1 Celsius degree. Pay attention. Now, what's meant by joule? Joule is an amount of heat that is needed to raise up 1 gram of pure water by 1 over 4.18 Celsius degree. So from these two definitions we can conclude that the calorie greater than the joule by 4.18. So if I want to change the measuring unit from calorie to joule, multiply 4.18, and if you want to change the measuring unit from joule to calorie, divided 4.18. The fourth concept is specific heat. Specific heat, what's meant by specific heat of a substance? Specific heat of the substance, it is the amount of heat energy that is needed to raise up the temperature of 1 gram of any substance. Pay attention here, 1 gram of any substance by 1 Celsius degree. Pay attention. Specific heat is characteristics property. What's meant by characteristics property? This means that the specific heat of the substance is constant. So if I told you the specific heat is 4.18, you must know this substance is water. The specific heat of water equal 4.18. Equal 4.18. So I can use specific heat to differentiate between different matter. For example, the specific heat of aluminium is 0.9. If I told you the specific heat of a substance is 0.9, so you can know the substance, this is a aluminium. Okay? Okay. Pay attention. The water has a high specific heat, equal 4.18. This means that the water needs more time to increase 1 gram of it by 1 Celsius degree. And this means that the specific heat of water is a constant value. But the specific heat changes by changing the state of matter. So the water in liquid state has a specific heat differs from the water in gaseous state and the water in solid state. Okay, so specific heat differs from the substance according to its physical state. If the substance, for example like the water, has a high specific heat, this means that I need a large amount of heat and I need a large amount of heat to raise up the temperature of 1 gram by 1 Celsius degree, and also I need large energy, more energy. I need to release more heat of energy to decrease its temperature by 1 Celsius degree. Okay. Now I have two processes, endothermic process and exothermic process. Endothermic process takes place when the temperature of the surrounding greater than the temperature of the system. So the heat energy now transfers from the surrounding to the system, and the system now absorbs heat energy, and this is called endothermic process. This is called endothermic process, and its value is positive, by positive sign. And we have another process which is exothermic process. In exothermic process, the temperature of the system is greater than the temperature of the surrounding. So here the heat energy will transfer from the system to the surrounding, and the system loses a thermal energy, and the total amount of energy will be with a negative sign. So if you calculate the amount of energy and you find it with a positive value, this is endothermic process. And if you calculate the amount of energy and you find it with a negative value, this is exothermic process. Thanks and goodbye. See you later with the next part in the first lesson. Thank you.